Dmitry had an interview for a staff data engineer position. It will be 2 parts video. Have a nice time watching.
Am I right that we have a kind of trying to understand these limitations? If we consider with some kind of IoT hub that collecting data from individual devices, like consolidate them together, is this my entry point, or there is the pops up stream available that already listen this and consuming the data? Where I should start?
You can start from ingestion. Consider IoT data coming. You can just consume the data.
For me, typically, then I start to design systems. It is clear it's based on the Google Cloud. And then we talk about data ingestion. We always have the options to choose either stream data or the batch data. And we can also start from bottom to top or top to bottom. So I will like jumping from one to another. Assuming if I just look to what we want to need to have, there are two main like use cases, business problems we want to solve. One of them is identify the faulty devices. And here I definitely would like to talk more about requirements. This is ideal path. I will talk more about requirements. I may like got the logic of faulty devices. I got it right. For example, I will get some sample of data, trying to consolidate raw logs from the single device, the faulty device. I wrote the logic, and if its condition is like beyond the range that we gave this device either fault or not, just to confirm with stakeholders that's machine learning, whatever, is it exactly what I'm doing before I implement this, because very often might be initial requirements, they, yeah, it is, but actually there are a couple more things. So just to clarify everything that I want to discuss using like just sample data. Of course, the ideal situation that the sample data could be provided and the logic, because this is really little information either for report, and I want to expand this, and I want to expand this through the writing, right? To have some kind of document that I can write initial proposal and document everything with little POC, collect the feedback before I'm going to build in big scale in production. But assuming here, the only thing I would like to know how frequently we want to see this and how we want to get notifications. And can maybe just assuming, maybe wrong. Of course, I will ask all those questions, but we don't have much time, and I will just give the many assumptions. We want to identify devices as fast as possible, and we should have some kind of like alerting and systems that we can, I don't know, the backend team or the engineering team or the product team about those kinds of devices, or maybe even just the customer service, trying to be aware, especially depends on the scale of the problem. It could be a couple device or it could be the bigger outage. And for these, we can have, in terms of data storage.
Sorry, Dmitry, we need to focus on requirements listed in the task.
It's not how you're going to deliver this. Then we can go from the source systems. So assuming we have pops up here, and that can generate the stream, and the data could be streamed into target destination. The first place where the data ideally would stream for me the important component is the type of the data, because the data could be like the very simple one is JSON. Ideally, it's gzip. Then we have the options for like using better for like serialization, like using Avro standard. Then there is the options to using Parquet. The reason depends on the support, like what happening in the industry is like Apache Iceberg we can write, and this is the ways how we can design. Based on my experience, in most of the cases, data was coming in JSON, and we can just keep in mind that assuming we currently have the default way, JSON give us benefit because devices can have many different event types, and the schema for every event type could be very different. That's why then we have the JSON format. We can have, and this is, for example, what I did. Then I designed telemetry for the game box. Assuming if we look to the schema of the JSON, we can have server timestamp, we can have source systems, so it's like couple very few fields initially that we can extract, but the most important is the body. The body will contain the payload where actually we have event types. I can also here, while I will process this data and writing to storage account, I can extract maybe event type. Every event type might have their own schema. This little number of fields that I expect to have. So my work as a data engineer, work with backend team to understand what schema and structure of the file we have, and just to make sure that it's convenient for process and consumption. And then, assuming we have something like this, we writing the data into storage account.
How could you consume the data and identify faulty devices?
Not coming yet to this point. For me, the very first point, I need to, because here we have somewhere, I don't know, IoT thing that passing the data to our stream, and then this stream can put the data into, I would use storage account, Google storage account. And here what's important for me is the structure of the storage account, because the data will coming in real time here. But for me, ideal, I don't want just write all the data into same folder in the storage account. That's why I want to have some kind of like partitions. And here I need to introduce the structure of the storage account. And usually what I do with telemetry events, I have folder year, folder month, folder day, and folder hour. This is my structure. And it means the stream will write to dedicated hour. Because our goal not only to identify this. For summary reports that we generate daily, we need historical information. Like for product usage, for the business metrics, we need the historical information. That anyway, even with some demands and like real-time insights as fast as possible for faulty devices, we have in mind that we need to store the data historically, because there is no other place outside of this to store the data historically. The landing zone for all the data, there it will be stored historic all events. In case if you want to build aggregation table, in case we want to analyze the data in the long range, or do like month over month, year over year, or sometimes the issue could be we calculate a bunch of metrics, we did the aggregations, and it was wrong. So we need to backfill the data. This is like my persistent storage for the data, and I just highlight that the folder structure that I'm convenient to work, because I have early partitions and I can work. From here, this is actually, I have different options what I can do. Even for the faulty devices, I can constantly look. For example, I can use a service that calls Dataflow, and currently with Spark serverless. With this simple thing, I can already hook it to this storage account. And here I have the options. One way I can just monitor the current partition, the current hour partition, and kind of like running it in some cadence to see if I have any devices out of the range. This is one option. Another option, I can use cloud functions. I forgot the name of those functions in GCP. It's, for example, Lambda functions in AWS. Those functions, they can work on the trigger. When every file will land to the storage account, it will trigger the function, service function, to take the file and process the file. Each file will be quite small. If Spark can look to the whole hour and will read over and over in some cadence, the function will trigger by every new file written to here, and analyze this. And in case if it have anything out of range, it can do the action or trigger or message. So basically passing it somewhere to dedicated person. I don't know. The question is, do we want to it as soon as possible, or we want like to have hourly report or like daily report?
For the faulty devices, we need a real-time processing job which should maintain sub-second latency.
Then probably the Spark as is and the batch not gonna work. But Spark has another feature that calls structure streaming. In this case, the structure streaming, let me do it different. Then I did for the gaming, I used the structure streaming. It was listened directly to the stream, but I used Apache Kafka. It was in real time consume data from the topics coming from Kafka. And as soon as new data coming to you, and I use the PySpark to read the data and do any kind of logic I want. This is another way. In this case, we also can analyze and do action, because our goal just to read incoming file, to process this, and do the next best action out of this, to communicate the person, lock the ticket, but do anything. For real time, I see just two options. One, directly hook to the stream and do this analysis with Apache Spark streaming. I know about AWS. I can use, for example, instead of PubSub, I can use the Kinesis stream. And Kinesis stream allows us to use the SQL right on the stream. I assume the Google GCP PubSub SQL. I assume there is a similar approach to the write, consume the, and for example, the Kafka works in the same way. We have the same way of reading and analyze the data, or like Apache Flink, just hook to the stream. So here, instead of, so for example, this is Apache Spark structure streaming, but it could be the same like Flink. But I think GCP Chef's own service do the same. But the typical idea for these options is to get queue my files in queue and process them as soon as they're coming. So I can process each file and do the next best action if it's out of the range. It's very straightforward.
You chose Apache Spark to maintain sub-second latency, but you set up a window for streaming jobs.
Apache Spark structure streaming will work in the way that it's whatever events it's coming based on the file base. It won't look to outside of the one file. This option with function, I also in the way that it will work on the file based. My assumption that I don't need to analyze multiple files to get this information, because I assume that each file, each event will have the device. That's a good point. You're talking about that, for example, device start working and it's sending the telemetry to us, coming in multiple files, and that one file coming, it's normal, and then another coming. For this, maybe I need better understand requirements in terms of what events generate. One file, is it enough for us or not? Do we need more than one file? Do we need to look to particular window to identify the fault? Because here it tells us that the device ID and temperature is just one record in the whole data set is off, and it will trigger. But maybe if we would have like, it's not just one off, it's for consistent time, like, 5 minutes, 10 minutes, or better to, the problem for me looks like not just the device little off, but it just was certain temperature, then it's a jump, and then it's come back. I want to identify those spikes. And for these, then I need to come up with additional requirements. Can we define the window for last like 15, 20 minutes? And then we have our stream of data, and we have buffer area where we can look to this particular window for like 20, 30 minutes and analyze on the fly this particular window that's coming through.
Let's assume that we will have 1 million messages per minute in JSON format. What time window will you set?
1 million events per minute. For me, it's nothing crazy, 1 million events. 5 minutes should work.
How do you define a window for a streaming job?
I will define based on the capacity, first of business requirements, and the second, the capacity of my systems. Then I work with Kafka. I have number of partitions, how much I can scale it, how much process I have, because to have efficient latency, I don't want to build the big queue, so I want that events process as soon as they come. For me, usually it's try. You can start and then increase it. Depends on the needs.
What storage will you use for this real-time data?
It's a Google Storage account, the same as S3 and AWS. For me, it's important that the structure I maintain here, and then the data is written here, like appending nonstop.
What about batch processes to produce daily summary reports?
Now we're coming to the batch. And here, first of all, we should make the engineering decisions. What our primary data warehouse, because we have the options. Do we want to have like Lakehouse, data lake, or data warehouse? And this is something that either organizations already have and we continue to use, or if organization doesn't have, then my goal is to come up with and run like POC on this to tell the pros and cons of every approach to like collectively decide, for example, what will suitable for machine learning. Machine learning team have some requirements to consume the data, and maybe for them it's easier to consume data from GCS versus like BigQuery data warehouse, or maybe they come directly to data warehouse. So I don't want just adding one more tool on top, and I want to highlight just two options, and both of them will work brilliantly for our reporting solutions. The very first one, we can use traditional data warehouse approach that's very suitable for business intelligence and reports as BI. It means the data from the storage account will be ingested into BigQuery. Here we have the options. We can not ingest the data, copy physically the data. We can introduce the external tables, and then they use BigQuery compute to read the data with the BigQuery. Because we have lots of big volume of data, we definitely need to organize the data inside the data warehouse. And for this, I like to use approach. Sometimes it calls medallion architecture, or it have the different ways like layers inside. If in case of medallion architecture, we can have bronze, silver, gold, or it could be just staging area and like a business where we have the facts, and the data will be. Assume we decide to push data inside BigQuery storage, and the data will be available in the bronze. And then I need to apply some business logic, right, to do aggregations and calculations. And I can use the SQL for this. But what I like to do for this kind of task is using dbt, because dbt framework is really good to convert the business logic into SQL logic. And it also have out-of-the-box testings and documentations. That is really good to have. Assuming I'm pushing data here in the bronze or staging as is, and then I introduce dbt, so I have dbt source to read the bronze, and then after reading the bronze, I can do some kind of transformations. Here we discuss that we have data in nested payloads. We need basically unpacked it, and then I had the Xbox telemetry. I had the same case. I have the bronze as is, but I use not the data warehouse. I use the Lakehouse approach, and I will cover this as well. The bronze layer I have as is as a table in BigQuery, and the silver layer depends on event type. I can create the staging tables, depends on events. There is certain events with their schema because I want to flatten my JSON. And because it has different events, have different schema, I need to group them and like split one bronze table in like dozen different silver tables with flattened structure. And then I can have my aggregation and transformations to build the fact tables. For example, using the popular approach like dimensional modeling, then I have like fact tables and some dimensions tables. We can also track some historical changes of the product names. We slowly change dimensions. And this will produce like my fact table, star schema. I can hook to BI, Looker, Tableau whatever we want, and we have the dashboards, and we can schedule them. The alternative approach here, it's avoiding to use the BigQuery completely, and then we can just continue to use the storage accounts. And in this case, we can start even using the Lakehouse. Right now, Apache Iceberg is very popular, and then there are a bunch of options to use here. It means now what we will have storage accounts or folders inside GCS that will serve as a bronze, as a silver, and as a gold. And I can use Apache Spark to moving the data from here. Data coming in JSON is not very efficient. The best way is Parquet. I can use the Apache Spark, read the data, and basically do the computational work with data frames and PySpark. Here we need to decide what we want to, as a file format, we want to use Parquet because it's columnar storage, good compressions, and this is best choice for these analytics use cases. We want to leverage, for example, window functions, do the merge statements, update those ACID compliant commands. That's why we want to use the Lakehouse approach. And default one for Spark, for example, it was for a very long time is Delta, but right now Apache Iceberg is more popular. Then we can decide, okay, we want to have the Apache Iceberg data catalog, or like just Iceberg catalog, and Iceberg catalog will hold all the metadata, like the table names and namespaces, and then Apache Spark will move the data, do computational work. In terms of how frequently I can run, for the bronze and silver, I can run it pretty often. I even can still have the streaming solution because this is with Spark structure streaming because it's appending only, no any window function, we just collecting events. But the safe one would be, because here we have data partitioned by hourly, we can have the batch process running every hour. It will process the data and saving here, and then we will move from silver to gold. Maybe we will run it not every hour, because in many cases you might need to have some window functions. We need to analyze beyond the last hour, like, for example, for last 24 hours, this bigger data set, bigger volume. And here we also can have, instead of just simple append and ingest, we can use the merge command, complicated things related to dimensional modeling. Yeah, but as a result, those both ways will create us fact tables that we can fit into reporting to generate those reports.
How would you design the storage schema for the batch reports in the BigQuery to optimize both the cost and the performance?
BigQuery work as a service, and it's basically will work with anything, trying to performing well. Definitely, if we talk about performance, then my options to have external storage and query data from here versus copy data physically in BigQuery. Copy data physically in BigQuery, it's already will improved a lot. And then we come to the point that how we can store or organize data inside BigQuery, because BigQuery is distributed computing. Data is distributed among machines, and we want to avoid data skew. It's important the data distribution evenly across the nodes in the cluster. I didn't work recently with BigQuery. I just understand overall how the distributed system works. The data distribution, we should avoid any data skew, and we optionally can use the partitions. Different systems like Snowflake have the cluster key, the Redshift have the sort key. Different systems have different names of those things, but there is techniques how you design the tables and fact tables. And for example, if I go to BigQuery optimization, it should go through the steps that tell me what kind of things I need to consider, because here it's just general rules like, okay, please use where condition on your partition. My goal is to decrease number of data with scanning, right? We don't want to let users read the data for last 2 years in the raw format. For me, First, it's data governance, how I can control the access to the system for the users. We talk about business users who doesn't care about cost or anything, and they don't know the difference about aggregated data and raw data. I want to prevent them to coming and, for example, query my bronze or silver raw label data. I want that they only focusing on aggregated data, and I want also track, because I can track the cost, and I can track the cost by the query, can proactively identify all the queries that running really long time. We've also enforce the timeouts. I can also add the workloads, and I can assign different users to different workloads. For nightly
What will be the right partitioning key?
TL and data engineering team, we can maybe give them more rules and power, versus on the business users, we want to limited number of concurrent queries and or overall time the query is running. It's just a bunch of techniques that can help us avoid those big queries. And from data engineering perspective, my goal just to design each table right in the way, and there are not many room. It's basically how we can distribute the data and what partitions or indexes we can use for the tables. Based on requirements, what I see, the good one is the region, because they won't do it by region. And for example, the users might come in BI tool and uses by region. But based on my experience, it's always good to have the data as well. So if the data is like just must have, having just per region, and imagine you have lots and lots of data for the last like 10 years or 3 years, could be very expensive still. That's why we want to agree with business user, can we just look maybe last 30 days of data by default? And then I can have the partition by day, and then at the same time by regions. And then we calculate our metrics, average temperature and faulty readings.
If regions telemetry data stops arriving, how will you investigate and resolve the issue?
Exactly for this case, like these systems that we built, it should leverage data observability. So we should track the metrics, and especially for telemetry systems, we can build the systems that will track the number of files per hour, number of rows per file, and so on, and many other things. And then I can use services either that Google Cloud provides or external one like a Datadog, Elasticsearch, where I can write the metrics. And then because I have historical metrics, my pattern, the data coming by region, I don't know, by device type, by something, my time series data, and then I can create alerts in case if we have to drop here. Of course, we have alerts if our pipeline is failed, like schema change or something. If we're using DBT, we can also track all the business transformations if something off. But if we talk about data coming here, so our stream's not writing, I can track, even here, I can collect the statistics, how much data processed by stream, by certain region, and then I can create alerts. In case if it failed, I can investigate. And the very first step, I need to go to backend team. And usually we can also implement incident systems, and we can even automate these. For example, in my company, we use system. If something breaks, it will create the incident. It will assign on-call engineer. It will invite all the engineers together in the Slack so they can collaboratively work. But for me, the most important to first, I will check that we don't have any out gauge here in particular region. And I think this information should be aware in the dedicated space. And then I can starting to investigate, okay, why it's failed. Do I have any logs here? Maybe data is here, but not here, right? Is one story. If I don't have here, if I don't have here, then I come to here. If you mention the region, this is actually a good point. This thing, we can also, if region so important, and usually it is, then we can have region here. This also will help us if we will add our stream will come into the region, and then we can monitor each of them. And assuming that there are different streams coming from the different regions. I think also important information here is to any PI data. Maybe we don't have any PI data coming to here, but sometimes the telemetry systems might send you PI data that before actual put it here, you need to exclude any PI data.
How will you ensure that the system meets security and compliance requirements?
I would start from, if I'm responsible for the designing the systems, I need to consult with the legal team just to understand what kind of requirements we have, because I need to understand what their local laws in terms of PI data. Of course, for me, the best option is to avoid to put any PI data to here. And if it's the case, then we just need to make sure that we're not writing any PI data here. And this is what is happening here. Usually I can work with data platform team together to make sure that whatever IoT device giving us here, then the project I work with Kafka, have this service that calls Data Shield. And we have two. We have Data Shield and we have another one for all schema. Actually, for us, the schema was very important. We use protobuf. So there's two additional services we use. Protobuf is control the schema. Here you can define what columns you're writing to here. Whatever stream you have, it first will depend on this one. And it only the columns that available in protobuf, these are like schema registry, you will let to put to write. The second one, if for some data is coming, like for example IP address, we use the data shield service to encrypt this data. In very rare cases, for machine learning team, exactly IP address, they need IP address for their, like they built the service like the bot protections for authentication process, and they got exemption for IP address. In this case, my goal is to make sure that this IP address that's flowing in BigQuery here, it's hidden from the majority of the users, and only machine learning team with their dedicated role and permissions can access this data.
If incoming telemetry suddenly doubles, how would you scale the pipeline without downtime?
We're using the cloud services. For me, I would rely on autoscale from starting. That's the primary benefit. And even with BigQuery, even with Apache Spark serverless, there is the way to use the autoscale feature, then we should use it. Otherwise, we can create the custom rules. We can monitor the performance of the systems in terms of like CPU, input, output reads, and so on. And we can create custom rules in case if we see the spike, or for example, I don't know, with some like really cold event happening, we can predefine this. If we see the spike, it will increase the capacity of the systems. And then the spike is drops, it will decrease. But hopefully there is the service, we're using the cloud services that have this capability out of the box. And the downside of this process, usually you do this after the fact that failures, your production failed, you did analysis, you realize it's failed because you didn't scale the system well. And then you're coming to the point, yeah, we need actually to do this. I forgot the name. In Amazon, we used to write the document why it's failed. I forgot the exact name of this document, but the idea that you explain why it happened and why this happened, like many whys. It's COI document, this one, correction of error. Exactly, and then you can, okay, now is a solution, we're gonna implement this autoscale feature. That's why another good thing here, I forgot to mention, and I did this for telemetry with gaming. With the gaming, you have the problem, then you design the system, you only have the really tiny bits of data from development team, and then you release the new game and your spike like skyrocket, and then like it's flattened. That's why you need to do the stress test. And for the whole thing, whatever we're going to design here, we do the stress test. And to do so in my environment that I use for the gaming, first of all, I use infrastructure as a code for everything. I didn't go in UI and create this. I use Terraform to create all the resources. And then I can, with one click, I can spin up the new environment. And then I work with the system who generate events. They synthetically generate 10x events, what we expect from production. Those events, they start coming to here, and this stress test help us to find all the like problem spots. It's important, especially in the gaming. And assume it's for any system is good to have. Depends if you have capacity to do so.
What are the possible points of failure for this design?
For me, every streaming like this real-time thing coming in the cost, and the rest could be so many possibilities why stream can be off, nature of streaming, and even then I use Apache Spark streaming. It's sometimes failure just very hard to troubleshoot, and I create the Databricks support tickets trying to go to the root cause. The one thing is how to monitor this system effectively. This is about the streaming and how you can scale, like size the systems right for your workload. So you can understand, and probably the stress test and monitoring, those two things can help you to scale it right and proactively monitoring. A lot of depends on these things. And another downside to streaming, it takes longer for you to recover because you need to make sure you have the checkpoint. If you restart the system, it should start from checkpoint without any duplication of the data. That's the challenging. Everything else, like the failures is happening here, very frequent could be the schema change. Because we have the JSON that doesn't really care about schema, but soon as we're coming to BigQuery or here, we have the table. We have the feature of schema evolution in the tables that might help. But as soon as schema change, it could be break. Also, frequently inside your payload, you can get some crazy character that doesn't supported by BigQuery, or like it just your whatever your process, your job will fail because unknown symbol, or you expect to have number, but it's somehow coming like a string, and then you need to go through these and fix. The very helpful sometimes is to have the data contracts. Then and the protobuf, it's part of data contracts. For example, work with backend team, and you agree what kind of events, what their formats, what's the string length, and so on. So you have the agreement and contract, the data contract that will enforce the quality to avoid all those failures.